Okay, welcome back. I apologize for the ending of the last video. Come to find out, it was a very simple and overlooked feature on my behalf here. So in order for our declarations to be recognized within our source file, we need to actually include this file into our program, into our CPP file. Otherwise, it doesn't know to communicate with it. And so in order to do that, we just want to simply make an include statement. And to include a header file, we're going to need to put it inside of quotation marks and then put the exact name of the header file with the extension inside of the quotations. Again, I apologize for that. It was not the names not syncing up. It was simply that it could not read the declarations from the other file there. And so now everything is working appropriately. One more thing to note, we do want to go ahead and add a couple of end line commands to the end of these statements to keep things nice and tidy within our program. And before, I wanted to just demonstrate how far we've come so far. It seems like a lot of jargon, but it's going to be for the best. So if we go and run it in the debugger, we see that it displays, here we'll go through this one step at a time. First, it's going to display this introduction text, welcome to the Haunted House Adventure game. Then it's going to display this first question. You've arrived at the outskirts of town at a haunted mansion. There is a front and a back door. How do you wish to proceed? Which are the values we set here. Then it's currently running our while loop. It checks our, it puts our output for our player choice, which is enter your choice 1 or 2. And it's currently checking for white space as I try and enter. It's ignoring all of this empty space that I'm trying to enter. And then if I were to enter, let's say, to check if it's an integer, if I just entered the word hello, it's going to tell me invalid selection. Please enter a 1 or 2. If I were to enter a big number, that is not what we're looking for. It would say the same thing. But if I were to enter a 1 or a 2, then it's going to display you have entered the correct number. It's going to exit the program, and that's going to be it. So I just wanted to do this little demonstration just to test and show you the importance of doing error checking with a program such as this. There can be instances where you might prompt the user to enter an A or a B, but instead of an A or a B, they enter, let's say, an A or a B. And if it's not coded properly, then it won't understand your inputs. So just showing that it is very important to handle your errors and account for every instance when you're programming so that you can get the exact desired result every single time that you want out of your user. Is there different ways to do this? Absolutely. But this is just one simple way that I'm using to demonstrate in order to show a lot of different features such as the while loops, the if-else statements, different function creations, the send fail, and other such functions like this, like the send clear and all this. So now that we've got a little taste of what we're working with, okay, great. So we can enter 1 and we get the correct number. We can enter 2, we've got the correct number, and pretty much anything else is gonna fail. It's just going to send us through this while loop over and over again until we get the desired result. So now that that test is over with to demonstrate, we're going to actually get our actual output that we're looking for. And for that, we're going to need another function. It's going to be called display text. But this one is going to do 2 different things. And we'll go and shoot over to our declarations, and I can show you what it's all about. So instead, we've been working with void functions so far. Instead of doing that, we're going to want a function with a return type. And in order for it to know what type we want to return, we declare it like how we would in a variable. So we're going to call, which we're going to need to include our using namespace standard here so that we can use our string. So it's going to be a string type function. We called it display text. Let me just double check. Yep, display text. And we're also doing something different here because we're not taking in any parameters here, but on this variable on this function we're going to want to take in 3 different variables. And so in our declaration we're going to tell it what kind of variables we want it to input. And for this we're going to take in an integer, a string, and another string. And as far as our declaration goes, that's as far as we're going to need for right here. And we're going to want to shoot over here, create some empty space here, and then we're going to create define our function here. Now again, defining our function is going to tell it what we actually want it to do in the middle of our program, as opposed to the declaration simply being the announcement that it exists. And so when we define our function here, we told it that it was going to want 3 parameters. So we're going to want to name these parameters. The first one was an integer, and we can name it player input. And then it was a string. We can just call this, let's see, we'll call it outcome 1, and the next string will be outcome 2. And so what are we doing here? We're going to take the player input that we received via the senX variable, and we're going to feed it through this. And we're going to tell our function to do a couple different things based on the input that we get from the player. Now, in order to do this, we're going to need a couple of if statements. But before we do that, let's just comment what we're doing so we can keep with our good practice. So if the player enters a 1, then display the text stored in outcome 1. No, it's spelled this way. And so we're going to make this if statement that we just talked about in the comments. If player input is equal to 1, then do this. Now I just want to note really quickly, I forgot to note this last time, when we're using a comparative operator as opposed to an assignment operator, we're going to want to use a double equal sign. So what we're doing here is saying, does the value inside of player input equal the same thing as a 1? And that's different than saying int x equals 0, because here we're assigning this variable the value of 0. A very important distinction, something easily overlooked sometimes, even when in the midst of programming. You may just forget that second equal sign. So it's just important to note in that regard. And I'll just add one more comment so we don't forget. The value stored in the variable x from above is the same value as player input. Just so we don't forget, because it can get a little confusing passing values between functions. And so let's see, if it enters 1, then we're going to want to output the outcome 1, which I copy and pasted this earlier, but outcome 1 is door 1 here, which essentially ends in a loss. So if the player enters outcome 1, we just want to play this outcome 1 text, and then we want to exit the program because it was an outcome that ended in the player losing. However, if player input is equal to a 2, then we want to return the value that is stored in outcome 2. Now return is going to take this value stored in outcome 2, which is going to be, here, we'll go ahead and do it here, door 1 and door 2. So this outcome here is going to be the value passed through this function call. So when we call it, we're saying display text, we want to pass in value x, x becomes player input, door 1 becomes outcome 1, and door 2 becomes outcome 2, as long as it's being used within this function. These are the values that are going to be used and passed into it. So we're saying if player input equals 1, play outcome 1, which is the same as door 1, which ends in a player loss, therefore we end the game. If it's 2, x is passed into player input and it equals 2, we want to return outcome 2, which is the same as door 2, which continues the game. There's no loss at the end of this. So we want to return this value back to the player, and when we print out this statement, it's going to return this statement. So this cout, if the value entered was 2, we'll print out this statement. And when we are using a function that has return values, we need to have a return statement for each, either an exit or a return statement for each outcome of the function. And seeing as we have our checks and balances in place to already check and make sure the only values that can be input into this function is either 1 or 2, this should never occur, but it's always good to have all your bases covered just in case of a fatal error or a contingency that you didn't account for. So while this will essentially never occur, we're just going to have this in case, well, we'll just say to cover every possible outcome. Okay. And now that we have this in place, let's see, we can go ahead and we're going to want to keep things tidy, make a new line. Can go ahead and test this out. Display text must return a value. Let's see, what have I done? We have a return. We have a return. Oh, it's because it's returning nothing. And we need to return some sort of string because this value, this return value needs to be a string. So instead of just putting return, we need to have that. So actually, there we go. And we see the program won't even compile unless we have covered all our bases. It wants us to be sure, even if we're never going to get there. But we can go ahead and test where we're at so far. So if we enter a bunch of blank space or random nonsense, it's not going to let us continue until we select 1 or 2. So we select 1. Let's go through the front door. As you attempt to juggle the handle, the door is locked. Suddenly a false panel under your feet opens. You fall into a dark abyss you are never heard from again, and you lose. Program terminates, and that was a success. So what if we select 2? Let's go through the back door. The door is locked, or is unlocked and opens with an eerie creak. You walk inside to find a long abandoned kitchen. There is a door leading to your left and a staircase leading upstairs. Now the program's going to terminate right now because we don't have anything, but this is the outcome we want. So far we have a branch that leads in 2 different directions. We technically have a game here. We have a win state and a lose state. So we're just going to go a little bit further, and we're going to actually create a win state. Technically, this is the extent of the new implementations that we will be working with the program, but just to finish out things, we're going to, like I said, finish out the game itself and just create a win state so that we can say that we've completed our first program and that we do have indeed a functioning, fully fledged game. Oh, actually, I take that back. We do have one last thing that we need to implement that we haven't really accounted for thus far. Very minor, and it consists of clearing the input buffer before we run another while loop here. So let's just go ahead and make sure we stay up to date with our comments here. This will check to see if we have a 1 or a 2 and return the appropriate values. So once we've reached this point, we're going to want to, well, let's see. First, we can go ahead and output the, so assuming that the player went with number 2, it's going to output this line of dialogue, right? Which asks you where you want to go. So after that, we're going to want to say, enter 1 for left door. And then we'll do an end line here. Oh, pardon me. Or we can enter 2 for staircase. And after this, we're going to want to just keep up with our comments, display the next options available to the player. And then we're going to want to reset any error flags and clear the input buffer before entering another loop. And this will essentially account for any previous errors the player may have entered. And to do this, we just need to do a character input.clear statement. And then make sure that we ignore anything that is not within our numerical limits. Stop when we read a new line. Nope, stream. And we've already done this before, so I guess it's nothing new, but we want to make sure we clear our input buffers again and just check for any, or reset any error flags that we may have had. Because this input system can be finicky. Whenever we do all of this jargon right here, the input buffer has registered an error. And so when we clear it, we want to reset it so that it doesn't know that it's being, there's no error flags. And so that the computer can be calm and it can just, go about its business and be happy with life as it is. And so just to finish out what we have here, we're going to, again, not good practice, but this is going to work for our purposes here. And I don't want to have this video go on much longer, as it's already getting quite lengthy. But we're going to go through our error checking loop one more time, as that's essential to making sure we get the proper input, which again, it's going to show the player choice string. It's going to check for white space, gather input, check for integers, make sure it is an integer, check if it's 1 or 2, and if it is, it's going to break out of this while loop and essentially allow us to finish the game here. Which, if you remember up here, after we break out of our while loop, we want to call our display text function. But since we are in a different part of the house, and this is a good demonstration on why it's so important to create these functions. You see, instead of typing out all of this and all of this, I can simply call this function and then put in the variables that I want to send through the function. And it's as simple as this. I just saved myself so much time by creating these functions. Now, let's say I wanted to do it again, and again, and again, and again. If I wanted the game to go on for another, 20, 30, however many avenues and branches, all of this has just saved me so much time. And I hope that this demonstrates the effectiveness of creating functions, creating variables, placing blocks of code inside of these functions to be called later. It just keeps things tidy. It keeps them organized. It keeps it, it's going to save time for you. It's going to help other developers see your code better. But enough rambling for now. Let's see the final result. And this is going to be the end of the program. So let's see if we got a game here. Okay, so we're on the outskirts of town. We saw this part. If we press 1, we know we're going to die, so let's press 2. Door is unlocked with an eerie creak. Oh, it looks like we forgot to tell the player to enter his choice. Let's see. For staircase, left for door. Okay, interesting. So why isn't this displaying our player choice? Let's see. Interesting. So, as far as this is concerned, sorry, I'm just referencing my notes here. Ah, I see. Okay. Something as simple as one character missing can cause so much to go wrong. And there it is. Perfect. Now I do see another minor thing that we probably don't want. We want the player choice to show on the same line here. Okay, so back to where we were. I apologize for that. So we want to enter our choice. We're going to go through the back door. The door is unlocked and opens with an eerie creak. You walk inside to find a long abandoned kitchen. There's a door leading left and a staircase leading upstairs. Enter 1 for left door, enter 2 for staircase. Okay, well, let's make sure our error checking is still working. Okay, invalid selection. It ignores our empty inputs. That's invalid as well. It keeps telling us to use a 1 or a 2. So let's try the left door. As you enter the door, a ghastly sight meets your eyes. A mummy reaches out and grabs you. You're unable to escape and you are never heard from again. You lose. Game enters its exit state and the program terminates. Well, there's only one more way to go. Let's try going to the back door. And then let's try the staircase. Walking up the staircase, you are met with a bright light. Squinting as you proceed, you suddenly jolt awake. Come to find out, it was a bad dream. You win. And there we go. We have just effectively created a text-based adventure game using the C++ programming language. And along the way, we learned about include statements, the IOStream, the string library, as well as how to include our header statement into the source file to be referenced. We learned that using a namespace standard can save us a lot of headache when it comes to naming conventions, but also to be wary of such naming conventions so that we don't override or create functions and variables with the same names within the standard naming space, for example. We've learned that our int main function is what handles the majority of our code, and is, in this instance, is what's going to be running our program for the most part. We learned that we can declare our variables and our functions inside of the header for better usage within our source file or our CPP file extension. We've learned that the variables are things that are stored into memory upon our definition. We can name them many different types, whether it be an integer, a bool, string, character, or many other types as well. And once we define it, it is stored in memory. We've worked through examples with integers, with strings. We demonstrated how to keep our strings nice and tidy and within a readable scope here by using the / character and breaking the strings up into more sizable readable chunks. We've learned how to use our cout system, which is short for character output. This allows to output anything we put after it into the console, be it a variable or a direct string or integer or any other type of value. We learned that using endl at the end of our cout statements will allow us to create a new line at the end. This keeps our console looking tidy and readable. We've learned how a while loop works, that there is a condition that you set, and as long as this condition in the parentheses is true, the code inside of these curly brackets will continue to execute until this condition is met with a false return. We've learned how to make function calls to other functions that we have also created outside of our main function. Within these said functions, we've learned how to check the character input using the character input.peek function, and we checked and peeked to see if there is white space. We've also learned how to ignore certain types of input that we do not want based on what our user will be inputting. We've learned how to ignore values that are outside the bounds of our numeric limits, namely characters or strings, letters, for example. And after that, we want to stop checking and ignoring as soon as we hit a new line after the character's input. We have also learned to take a character input from the user and store that input they will give us into a variable to be referenced later. We have learned about if and else statements so that we can say if this doesn't work, then this will execute. We've learned what the OR operator is here today and how it will say if x is equal to 1 or 2, then do this. So it allows us to add multiple conditions within our if statement that will be executed according to what our character input is that we received from the user. We've learned how to also have a function that is declared as something other than a string type so that it will return a type. And we've also learned how it takes in different parameters based on different values that we feed into it. In this instance, we used our character input X and the strings door1, door2, kitchen1, kitchen2, and this was able to feed through our function here. It went we turned X into our variable player input temporarily while it was used in this function, and we referenced it as such. If it equaled 1, we did this. If it equaled 2, we did this. And we made sure to return or exit in every branch of our function that was not titled as a void function. So in conclusion, I think we have learned quite a lot here today over the course of these few videos. Thank you for stopping by and going through this with me. I hope that it was enjoyable and informative, and I hope you see how the C++ language has a lot of flexibility and power when it comes to programming, as it can allow you to create a vast array of many different things, not just text-based adventure games. But thank you again for your time. I hope you learned something today, and I hope to help you all learn again in the future. Have a good one.